A magnitude 5.2 earthquake struck Northern California on the morning of Sunday, December 15, 2024, at approximately 10:08 a.m. local time. The earthquake 3D globe also recorded recent seismic activity, including a magnitude 3.0 earthquake in Alaska and a smaller 1.5 magnitude tremor earlier the same morning. However, the 5.2 quake offshore near Eureka was the most significant event of the day. This recent earthquake may be part of an ongoing aftershock sequence following the magnitude 7.0 earthquake that struck the region just over a week ago. The timing and intensity of this aftershock are unusual, as aftershocks typically decrease in magnitude and frequency over time. Coastal areas such as Eureka, Crescent City, and potentially Fort Bragg reported feeling the tremor, making it the largest aftershock since the main 7.0 quake. The aftershock occurred approximately 6.2 miles below the surface and was located further west along the tectonic plate boundary. The December 5, 2024 magnitude 7.0 earthquake, the strongest in years for Northern California, caused significant shaking across the region, with notable impacts reported as far inland as Chico. Since then, most aftershocks have concentrated along the southern branch of the fault system, trending toward the northern segment of the San Andreas Fault. Additionally, some activity has been detected near the Cascadia subduction zone, a tectonically volatile region recognized as overdue for a significant seismic event. The Cascadia subduction zone, a megathrust fault capable of generating earthquakes of magnitude 9.0 or higher, has an average rupture interval of 291 years for large events over the past 4,000 years. Over a 6,000-year span, the average interval increases slightly to 344 years. With 324 years having elapsed since the last major rupture in 1700, the current interval surpasses 81% of historical intervals over the past 10,000 years and exceeds 93% of intervals in the past 6,000 years. These statistics strongly suggest the region is at an elevated risk of experiencing a major earthquake soon. Partial ruptures in the southern section of the Cascadia subduction zone can generate earthquakes of magnitudes 8.5 to 8.6, while full margin ruptures can result in magnitudes exceeding 9.0. Recent seismic patterns, including activity along the Blanco fracture zone and the Gorda ridges, have heightened concern. These tectonic boundaries continuously generate stress that contributes to strain along the southern end of the Cascadia subduction zone. Historical records show that 3/4 of intervals longer than 323 years have resulted in full margin ruptures, making the current interval particularly concerning. Recent earthquakes at depths of 12 to 16 miles within the locked zone of the Cascadia subduction zone underscore the growing tension. Unlike surface faults that exhibit frequent smaller quakes as precursors, the Cascadia subduction zone typically accumulates stress for centuries before releasing it in a single catastrophic event. The locked zone, where this strain builds, is critical for assessing seismic risks. Notable seismic activity in the past week includes a mix of shallow and deep earthquakes, particularly near the Table Mountain Fault and offshore areas like Coos Bay. Deep earthquakes within the locked zone are of particular significance as they suggest increasing stress at depth. Although direct seismic events along the Cascadia subduction zone remain absent, upstream patterns point to significant strain accumulation. Considering historical trends, geological data, and recent seismic activity, there is a heightened likelihood of a significant earthquake in the near future. Residents and authorities in the region are advised to remain vigilant and prioritize preparedness measures to mitigate potential risks associated with this tectonically active area. The southern extent of the Cascadia subduction zone remains under considerable geological strain, making it a region of critical importance for seismic monitoring. Tremor events, recorded predominantly below the locked section of the subduction zone, occur in the deeper regions of the Earth's crust. This locked section lies just offshore, extending approximately 10 miles beneath the surface. While a precise cartographic representation may not be readily available, the structure of the subduction zone can be visualized as a cross-sectional profile of the region's geology. This subduction zone extends beneath Northern California and plays a vital role in shaping the volcanic landscape of the Cascade Range. However, its southern reach does not extend beyond the Sacramento Valley, where the zone terminates. The deeper tremor activity in the area signals where tectonic strain is building. Specifically, this strain accumulates where the Gorda Plate is subducting beneath the North American Plate. Patterns in tremor activity reveal that the locked zone south of Northern California extends northward, connecting with regions as far as Queen Charlotte Sound. The northern segment of the Cascadia subduction zone is where full-margin ruptures capable of generating magnitude 9.0 plus earthquakes have historically occurred. In contrast, partial ruptures are more frequent in the southern portion. Historically, these partial ruptures have occurred every 220 to 240 years, but the current interval has significantly exceeded this average, raising concerns that the region is nearing a critical threshold for a major seismic event. Recent data indicates that tremor activity has been concentrated in the southern section of the Cascadia subduction zone. This activity points to ongoing adjustments in the region, where the locked zone accumulates stress as the Gorda Plate continues its slow descent. These processes are fundamental to the buildup of tension that ultimately results in major earthquakes. Notably, the Blanco fracture zone applies additional stress to the southern extent of the subduction zone, further amplifying the strain. In the past year, significant seismic movement has been recorded along the Gorda ridges, underscoring the heightened strain in southern Cascadia. Recent observations from the Petrolia seismograph station highlight increased activity following a 5.2 magnitude earthquake, accompanied by clusters of smaller quakes, including several in the magnitude 3 range. These events suggest that seismicity remains elevated along the plate boundary. The potential for a large-scale event, such as a magnitude 8.4 earthquake, poses significant risks. Such a quake would far surpass the devastation of the recent magnitude 7 earthquake, emphasizing the latent power of the Cascadia subduction zone. Geological evidence, such as tsunami deposits and ghost forests, submerged trees scarred by past seismic events, serves as a stark reminder of the region's seismic history. During a full margin rupture, coastal areas could experience land subsidence of several feet, triggering immediate tidal flooding, followed by a catastrophic tsunami capable of devastating coastal infrastructure. Over time, the land would gradually rise again, leaving behind a geological record of the event. Communities along the coast, particularly in scenic but vulnerable areas like Brookings and Gold Beach, face significant risks due to their proximity to this sleeping giant. While the timeline for a major seismic event remains uncertain, recent tremor activity indicates increasing tension. Experts compare the state of strain along the Cascadia subduction zone to that of the San Andreas Fault, suggesting that a significant rupture could occur with little warning. Elsewhere, seismic activity in Southern California has been relatively quiet, with no recent significant earthquakes exceeding magnitude 2.5. A 3.6 magnitude earthquake was recorded in Nevada, but overall activity in the region remains minimal. Since a recent magnitude 5.8 earthquake, 353 aftershocks have been recorded, with most being minor. Seismic activity in the Dunnigan Hills area, associated with the slow-moving Great Valley Thrust Fault, has also been limited to minor quakes of magnitude 2.2 and 2.3. In the northern Cascadia region, seismicity continues at depths of approximately 16 to 17 miles, which is unusual given that tremor activity typically occurs at shallower depths. These deeper tremors may reflect broader tectonic pressures influenced by the interplay between the Cascadia subduction zone and the San Andreas Fault. Monitoring efforts remain critical across the West Coast, where interconnected fault systems demand close scientific attention. While no immediate threat is certain, the evidence of mounting strain underscores the importance of preparedness for communities in this tectonically active region. Seismic Activity Update, Global and Regional Overview. Current observations reveal notable geological tension in several regions worldwide, signaling an ongoing accumulation of stress within the Earth's crust. Strain measurements at various depths suggest the potential for significant seismic events, though global seismic activity remains relatively moderate overall. North America, quiet yet persistent activity. The North American plate shows limited movement, with no major seismic events reported along critical fault systems such as the New Madrid Seismic Zone, NMSZ. Despite its history of notable seismicity, the NMSZ has been relatively subdued, with only minor activity observed in the vicinity of Pozos, Texas. Approximately 5 small earthquakes have been recorded in this area over the past month, a lower than average frequency compared to prior observations. This decline contrasts with typical activity levels, which are often influenced by the region's extensive oil fields and wastewater injection practices, factors known to induce minor seismicity. Interestingly, the West Coast has experienced a significant reduction in seismic activity since the magnitude 7 earthquake struck Northern California. This drop is somewhat unexpected for this tectonically active region. It may indicate a temporary relaxation of stress following the larger event, or suggest evolving seismic pressure patterns. However, experts remain vigilant as seismic quiet periods can precede significant earthquakes. New Madrid Seismic Zone, a surge in activity. In contrast, the New Madrid Seismic Zone has seen an uptick in activity. Over the past 30 days, 33 earthquakes have been recorded, a marked increase from the usual monthly average of 5 to 6 events. The most recent earthquake in this region, a magnitude 1.6 event, occurred on December 12th. While these events are relatively small, they indicate ongoing tectonic stress accumulation, which may culminate in larger seismic releases in the future. Global seismic highlights: Tonga, New Zealand, and the Arctic. On a global scale, the largest earthquake in the last 24 hours was a magnitude 5.9 event in the Tonga region at a depth of 132 miles. This earthquake occurred along the seismically active Tonga Trench, a zone renowned for its deep subduction-related seismicity. Smaller quakes along nearby plate boundaries further underscore the region's tectonic dynamism. In New Zealand, recent activity has concentrated near the South Island. A notable magnitude 4.7 earthquake occurred near the Northern Hikurangi Subduction Zone, HSZ, an area that remains under significant geological strain. Additionally, a magnitude 5.2 event was recorded at the zone's northern extremity. With historical records showing centuries of stress accumulation, the HSZ is considered a prime candidate for future megaquakes. Meanwhile, the Arctic experienced unusual activity, including a magnitude 4.5 earthquake in Greenland. Though infrequent, such events highlight the potential for tectonic activity in less studied regions. Volcanic and seismic developments in Hawaii. Hawaii continues to experience minor seismicity near Kilauea's summit. Recent observations reveal no substantial changes in volcanic activity, though the volcano remains active with persistent gas emissions from the summit's lava lake. Deformation data suggests a leveling off pattern following a recent inflation increase, reaching levels akin to those observed before eruptions earlier this year. This trend indicates the potential for renewed magma intrusion or another eruption in the near future, warranting close monitoring. Cascadia Subduction Zone, a growing concern. Signs of strain are increasingly evident along the Cascadia Subduction Zone, particularly in its southern segment. This area is a critical seismic hotspot, with the potential for significant earthquakes ranging from magnitude 8.1 to 9.1. Such an event would release immense energy, likely generating a tsunami with catastrophic consequences. Historical evidence confirms that these full-rupture earthquakes occur periodically, and experts agree that another is inevitable. The timeline remains uncertain, but recent stress indicators suggest the region may be approaching a critical threshold. Preparedness, an urgent priority. The recent magnitude 5.2 earthquake in Northern California underscores the ongoing seismic risks along the West Coast. As stress builds along major fault systems, preparedness is more important than ever. Coastal residents and those near fault lines are urged to develop emergency plans, secure essential supplies, and stay informed through regular updates. The underreporting of smaller earthquakes, especially those with magnitudes around 1.0, presents significant challenges to the accuracy and comprehensiveness of seismic monitoring systems. These minor seismic events, though seemingly inconsequential, provide critical data for scientists studying the distribution and dissipation of energy along fault systems. This information is essential for understanding the mechanics of fault movement and for assessing the long-term seismic risks associated with specific regions.